Well, what we're going to do is we're going to look how the least common denominator can let us add or subtract fractions that don't have the same denominator. So I'm going to start right away with an example. If I take 2 fifths and I'm going to add to it 8 fifteenths. Well, because the denominators are not the same, I don't have a way of blending these. So what I want to do is I want to make these the same. So I want to find the least common denominator. So 5 has factors of 1 and 5, and 15 has factors of 3 times 5. So the least common denominator would have all of these in it, which in that case the least common denominator is 15. So that's the highest power of these. So I want to change the denominators to 15. Well, I don't have to do anything to change here, but I have to change this one. So I'm going to use that multiply by 1 trick to alter this. And I'm going to multiply it by 1 in a format that makes my denominator 15. So I'm going to multiply it by 3 over 3. So that's going to give me 6 fifteenths. And now my denominator is the same, so I know my answer will have this denominator, and I add the tops. So to add fractions that don't have the same denominator, we find the LCD, and we multiply each term by 1 in the form of some number over some number, such that the term will develop the LCD in the denominator. And then we add what are now like fractions. And this is a common mathematical trick that we take things that we don't have a way of solving and we make it look like something that we have a way to solve. And in this case, we have a way of adding common denominators. So the way we change the way it looks is by multiplying by 1. We just use a form of 1 that makes it look like the thing we need. And that is extremely common. Most of the things that are called a mathematical trick are adding by 1 or, multiplying by 1 or adding 0, because those won't alter the things we have. So if I have 2/3 plus 1/8, I want a least common denominator. Well, my factors of 3 are 1 and 3, and my factors of 8 are 2 times 2 times 2, which we can write as 2 to the third. Well, I have a 3 and a 2 to the third, so my LCD is going to be 2 to the third times 3, or 8 times 3, which is 24. So I need to alter these terms so that they both have a denominator of 24. And so in this case, I need to multiply the denominator by 8. So I multiply that term by 1 in the form of 8 over 8. For this one, I need to multiply the denominator by 3. So I alter this by multiplying it by 1 in the form of 3 over 3. So I'll do my multiplication. Now I get 16 24ths plus 3 24ths. Now, because I have the same denominator now, my answer will have this denominator, And 16 plus 3 is 19. And I have my simplest form of the answer. The same thing happens with subtraction. If I have a subtraction, I need to find the least common denominator. So 11 is prime and 3 is prime. So the only LCD would be 3 times 11, or 33. So I need to take each term and multiply it by 1 in a form that will give me 33. So in this case, I need to multiply this side by 3 over 3. And in this case, I need to multiply it by 11 over 11. Multiply across the tops, 30 33rds minus 2 times 11 is 22 33rds. The bottom will be my common denominator, and the top will be the subtraction of the numerators. 30 minus 22 is 8. And I double check to make sure this is in the simplest form. So our mutation trick is working well for us. Let's see if we can get some complexities out of this. Okay? So let's look at kind of a similar problem that has the same denominator pairing, but it's a subtraction where we're taking 2/3 minus 10/11. So again, the LCD, well, 3 is prime and 11 is prime, so this is 3 times 11, it's 33 again. And I'm going to do the same thing. I'm going to multiply this one by 11 over 11 so that I get this in terms of 33. And I'm going to multiply this by 3 over 3. Again, forms of 1 so that the denominators give me the same denominator. And so I get 22 33rds minus 30 33rds. Now, this is the bigger number, so my answer is going to be negative. And so the difference between 30 and 22 is 8 33rds. Well, we can do this with variables. So if I have 5 minus y over 4, well, 5 is really 5 over 1. And so my common denominator is going to be the 4, because anything times 1 is 1. So I don't have to multiply this by anything because it already has 4. So I'm going to multiply 5 over 1 by some version of 1 so that this becomes 4. And that happens to be 4 over 4. So this becomes 20 fourths minus y over 4. Because I have the same denominator, I perform the operation on my numerator. And 20 minus y over 4 would be the answer for this with variable terms. Well, we can use common denominators to compare fractions, to get a feel for which is bigger or smaller. So if I have 3/8 and 14/40, well, the larger the denominator, the smaller the pieces are. So this has big pieces, and this has much smaller pieces. So I need to figure some way to compare them. Well, the common denominator is the best way. So my LCD, well, my factors of 8 is 2 cubed. We've been seeing that one come up a lot. And my factors of 40, well, that's 8 times 5, or 2 cubed times 5. So my LCD is going to take the greater power of all the prime factors. So my LCD is going to be 40. So I can transform these two numbers into fractions of 40. So 14/40 stays the same. But 3/8 I'm going to multiply by 1 such that I have to find the number that I multiplied by 8 that'll give me 40, which is 5. And so I get this multiplication will give me 40 on the bottom and 15 on the top. And so this is greater than this fraction. But that means we can come back up here and say, hey, 3/8 is bigger than 14/40 by 1/40. And so this is how we can kind of order and get comparisons on fractions. Let me erase my blackboard and look at some more of these. All right, so if I have a negative number and another negative fraction, again, this has bigger parts and this has smaller parts. So I need some way to compare. And that's going to be the LCD. Well, both of these are prime, so the LCD is going to be 3 times 7, or 21. So I'm going to convert these numbers to 21 by finding some version of 21 in the denominator, by finding some version of 1 that'll give me 21 in the denominator. So 7 times 3 is 21. And over here, well, this is going to need to be 7 over 7. So my new fraction is negative 6 sevenths. And this is negative, not sevenths, right? 2 times 3 is 6, and 7 times 3 is 21. That's what I wanted to make it, and that's what this does. My apologies for the little verbal slippage there. And then this one, the upstairs is 7, and the downstairs is 21. So this is bigger than this. And so I take this comparison and I come back up and, oh, this is bigger in absolute value, but these are negative numbers, aren't they? So negative 6 is bigger than negative 7. Glad I double checked myself, right? Sorry, you'll see sometimes I don't mind making mistakes in front of classes. If you were in my in-class lectures, I lecture without notes. I have the problems and I have them worked out so I can look at my notes, because I find that showing how to fix mistakes is just as important as showing the correct way. And so what I did is I looked at the absolute value and said, oh, this is the bigger absolute value, but I had to remember my signs. And so negative 6 is bigger than negative 7. In fact, the arrow portion of our less than or greater than points to the smaller number. And if we were to look at a number line, right, negative 7 is smaller than negative 6. And so when I first wrote that and came up here, I noticed my negative signs. I was like, oh yeah, got to look at my negative signs. And so I'll always, kind of double check yourself when you're doing these things. And I'll try to double check myself. So negative 2 sevenths is bigger than negative 1/3. Well, we can have ways of having these come into variables. So if I make x equals 1/3 and y equals negative 4/5, I can evaluate an expression by replacing the variables with what they represent. And so we've been seeing x and y as being whole numbers, but they can also be fractions. And so these expressions we have can hold any number that we come across. And so, in chapter 3, we were practicing with these being, positive and negative integers or whole value numbers. But even fractions can come into here. And so again, I have a common denominator problem. Both of these are prime. So my LCD is 3 times 5 because they're both prime, or 15. So what I need to do is find the number that will give this denominator to have this to go to 15. And that's going to be 5, but I do it in the form of 1. And for this one, it's going to be 3. So I do it in the form of 1. So that gives me 5/15 plus negative 20. Yeah, having a bad math day. Negative 12. 4 times 3 is 12/15. And so 5 plus negative 12, well, that's negative 7/15. And that's my answer. A good example that your textbook uses is, again, things that we measure. So we could say that a truck has freight, that it's loading from the dock, and 1/4 ton is computers, 1/3 ton is televisions, right? Like you could see, a forklift bringing in the pallets of the computers, and the weight is measured because you can only stack so much weight on a pallet. And so as the truck is being loaded, you know the weight coming through. And 3/8 tons of appliances. And so all this goes into a freight truck. Well, the trucks have weight limits on them. So if we want to find the total weight, we add up the weight of all of the components. And so since I have 3 denominators, I need to find the LCD for all 3. So my factors of 4 are 2 squared, my prime factors. My prime factors of 3 are 3, and my prime factors of 8 is 2 cubed. So of these shared prime factors, the largest exponent is 2 cubed. So my LCD will be 2 cubed times 3, or 8 times 3, which is 24. So I need to take each one of these terms and multiply the denominator by something that's going to give me 24. So for the first term, that's 6, because 6 times 4 is 24. So I write it in the form of 1. For 1/3, it's 8. So I write it in the form of 1, and I'm transforming this to something with a common denominator. And then for 8, it's going to be 3. Right? And so 24, 24, 24. So we have a common denominator. So this expression becomes 6/24 plus 8/24 plus 9/24. Well, they have the same denominator, so that will be the denominator of the answer. And then 6 plus 8 is 14, plus 9 is 23/24. And so this truck is carrying just under, a small fraction under 1 ton, or 23/4 of a ton. All right, that was Chapter 4, Section 5. I'll see you on Chapter 4, Section 6, where we're going to work on some things called complex fractions, and we'll look at how the order of operations is applied to fractions. See you on the other side.